Uh, Welcome back, ladies and gentlemen, and thank you very much for His Holiness for your attendance again this afternoon. I am going to chair the afternoon session and as well as tomorrow mornings. And just before starting, I describe briefly who I am and why I'm here. I am a cognitive neurobiologist from the Riken Brain Science Institute and also a part of the Kokoro Research Center, besides my other appointment in London and Singapore, because I am interested in biological mechanisms of the evolution and emergence of the human mind and intelligence out of our primate ancestors' brain. I think this is enough for my introduction. And this afternoon, I think we had a very good introductory session this morning about the global view of the Buddhism structure and also how it linked to a global view of the brain. And this afternoon, I think we are going to more focus on different aspects or more concrete, for the concrete discussions of the various aspects of the Buddhism and brain mechanisms of the consciousness, mind, and so on. So we have three speakers this afternoon who are the philosophers and also the physicists and mathematicians. And first we'd like to start with Professor Jay Garfield, who is a professor of the philosophy in Yale and National University of Singapore right now. And he is a professor of the philosophy of Buddhism. And I hope to hear from you the extension of what Zipa have introduced this morning at the last part about the Yogacara aspect, how it's linked to his consciousness and mind through the path of illusions, I hope. So please.
Thank you very much. And Your Holiness, it's a great pleasure to be back in your presence and a great honor to be able to talk with you. And again, I thank the Mind and Life Institute and the Kokoro Institute for making all of this possible, as well as all of the generous donors. Excuse me? I'm not working? Uh-oh. Is this better?
Yeah.
Okay, thank you. I'm not used to speaking through wires. This is something you understand, but I don't, Your Holiness. So, in a way, we'll be continuing the conversation we began over lunch. But this morning we heard very eloquently Thupten Jinpala and Richie Davidson give us the optimistic story about the possibility of knowledge of our own minds. And it's always important for somebody to deliver the bad news, the obstacles in that path. And so it's fallen to me to be the guy who talks about the obstacles. And I want to talk about that in terms of cognitive illusion, and partly from the Yogacara tradition, and partly from Western philosophical traditions that mirror that. And I'm going to talk in about 8 steps, and they'll be very quick. The first is to talk about the need for introspection and introspective knowledge in cognitive science. Then to talk about some examples of illusion with which we're familiar, and then to go from those examples of illusion to talking in specific about cognitive illusions and what I'm going to call the calibration problem that's very special for cognitive illusion.
How would you explain calibration?
Calibration, making sure that an instrument is actually accurate, how we actually make sure that a measurement is accurate. Then I'll turn to some Buddhist perspectives on this, first focusing on inner sense consciousness, on Manas Vijnana or Yi Wangsha. Then talk a little bit about reflexive awareness, Rangrik. Then move to talking about Western perspectives on cognitive illusion that parallel some of the Buddhist perspectives. Finish with a discussion of the big picture and draw a few conclusions. So that's the plan of action for today. We'll begin by talking about the real need for trained introspection, something that Thupten Jinpala emphasized this morning, and Richie Davidson. Because if our project is to try to understand the relationship between mind and brain, or consciousness and brain, then we need to be able to coordinate information that we have about people's experiences and the information that we get about behavior and the brain. And that requires two sets of observations. One will be an observation of inner experience, and one is an observation using machinery or using experimental apparatus of brain or behavior. And of course, untrained introspection is just as bad as any kind of untrained observation. So if we were trying to find out what kinds of animals lived in an area, and I didn't know the difference between various kinds of animals and didn't have very good eyesight, I'd be a terrible observer in that area. Similarly, we would want the kind of training for an internal observer that we want for an external observer. And so we all agree that trained introspection is a lot better than untrained introspection. Nonetheless, whenever we use introspective... Whenever we use first-person methods or introspective methods in science, there are going to be problems. That doesn't mean there are impossibilities, but there are problems. And those are the problems that I want to talk about. In particular, we have to be very careful of an illusion that's very easy for us to fall into and is very common, I think, in people who talk about the use of trained observers in cognitive science. And that is the illusion that when we just look inside, when we take a first-person stance, we have immediate, direct access to our minds as they are, and that introspection is, at least even in principle, in some sense, infallible. And so now I want to talk about cognitive illusion and calibration. The first thing we know is that any kind of perception is beset by illusions. There are illusions of hearing, illusions of vision, color perception, illusions, and so forth. And one of the things that's really important about these illusions is that even when we're aware of them, and even when we know how the illusion is produced, they don't go away. And introspection, because it's again a kind of sensory apprehension of our inner states, is also probably beset by illusions. And one of the problems with introspection is that we often don't even know what those illusions are, let alone the problem that even if we were aware of them, they might not go away. So I want to begin with a few easy examples of perceptual illusions to make that point. They're all perceptual, but the important point is that each of these perceptual illusions also has a conceptual or a cognitive dimension to it and involves a kind of cognitive illusion. And that dimension can be captured just by saying that even when we are experiencing these illusions, we can't say exactly what the nature of that experience is. We don't understand our own processing when we're processing them. And even though we know that we're making a mistake, we persist in making the mistake. The illusions are persistent. So the best known of these, and I know you've seen this before, Your Holiness, is the Mueller-Lyer illusion, where even though you and I both know that those two lines are exactly the same length, when we look at them, we can't help but see the one on the right as longer because of the arrows. And even knowing that it's an illusion doesn't make it go away. Shall I come back to that one? And when we see it in a natural circumstance like this, the same thing happens. Even though we can see and measure that those two vertical lines are the same length, the scenes make them look as though they're very different. And even measuring them doesn't give us the difference. There we can see them side by side. The lines are exactly the same length. We know that, but the illusion nonetheless persists. Yeah, and we have no idea how it's done as we're experiencing it.
I would have to measure.
Do you want to measure?
Okay, no, okay.
You'll trust me on this one?
Okay.
Your Holiness, I have no reason to deceive you.
That's right. That's why I trust you. Otherwise, I would like to take measure.
I understand that.
Okay.
Isn't that terrifying? So this is just ordinary visual illusion, and visual scientists understand how this is produced. Would you like another illusion, Your Holiness?
Yes. Usually, you see, look this way and look this way, some differences. Usually.
Yeah.
Oh.
Yeah, but it doesn't work. You see? Same thing happens. It's terrible.
Okay.
그 소리는 때는
Here's another one that's just as dramatic.
actually it's only saying that if you look sideways,
Yeah?
you have
Some of
less.
the differences.
Yeah, there's a
Well,
difference.
maybe a little bit less, but
Yeah.
it's still there. It's still there. Here's another nice one. Do you see how different the color is in that gray bar from one side to another? It goes from light to dark. It's very clear that the gray bar is not the same color all the way across until we take away its background.
Oh,
And then we see it's exactly the same color.
yes. Now this is clear.
Isn't that terrifying? And again, when we look at it, even if I click back and you know that it's an illusion, the illusion persists. So the terrible thing about illusions isn't that we're deceived by them, but it's that even when we know they're illusions, the deception remains. Now, when we get to cognitive illusions, things are even worse. Because one thing that we can do in the case of the perceptual illusions, as you yourself suggested, as in the case of the Mueller-Lyer illusion, is that we can calibrate, we can measure. We can say, okay, it looks to me like this line's longer than this one, but if I measure them, they're the same length. Or if maybe I'm seeing a color wrong and you're seeing it correctly, we can ask Jimpala what the correct color is and we can calibrate our vision. Because when we have independent observers of the same thing, we can figure out who's right and who's wrong. But calibration requires comparing different observers with the same object. And so when we're looking at introspection, when we're examining our own minds, we don't have distinct observers. We've got one observer. And so calibration can be very, very different. And for that reason, illusion, if it's present, can remain undetected. We can tell the Mueller-Lyer illusion is an illusion because we can get two independent fixes on it.
실 때문에 주나요나 아니 그 되나 시치로는 세제요 말와.
네.
이 노트요 그래서 원실 때문에 주나요나 야고 세단데 제제 미신다질 게지티지 제세요 버스. 실 때문에 주나요나 네 주나이 먹거나.
네.
뭐시마도야. 강겠.
Now, when we think about our awareness of our own inner states from a Buddhist perspective, we basically have two alternatives. We could either say that we're aware of an inner state because of a mental sense consciousness, a Yiwangsha, or we could say that we're aware of it because of reflexivity through Rangrig. And we'll see that there are problems in each case. Not insuperable problems, perhaps, but interesting obstacles to self-knowledge. So, as I said, the introspection is either going to be through Rangrig or through inner perception. So it's either a kind of higher order perception of one mental state by another, or a perception of a mental state by that state itself. And the problem is that if we're not already fully awakened, then any sense faculty that we have is going to be in some sense an impaired sense faculty, a sense faculty that's going to be subject to the superimposition of subject-object duality, of illusion, or simply conceptual superimposition on that perception. That's just the nature of human sense perception. And in the case of introspection, we can't always check to see what we are superimposing. Moreover, we already know that this could be a problem. At lunchtime today, we were talking about meditators from different traditions, and how a meditator, for instance, from an Orthodox Indian tradition, might meditate for a long time and be completely sure that he has observed correctly his Atman, his self, and that he finds that self and can tell you what its properties are. Where a long-term meditator from a Buddhist tradition might tell me at the same time that she has found no self, has found anatman, and can tell me about the experience of no self. And again, people from different lineages, different religions disagree with each other about what they find in introspection. And so we don't find an easy calibration just by comparing the deliverances of people who observe their own minds from different traditions. So we don't have a good way to calibrate those data. Now, if we turn to the Yogacara tradition, we find the wonderful analysis that comes from the Samdhinirmochana Sutra, elaborated by Acharya Vasubandhu, that all perception involves superimposing three natures on phenomena, the Rangshin Sum. And of course, the important one of those Rangshin for us, of those three natures, is the Parakalpita, or the Kuntak Rangshin. And the analysis that Vasubandhu gives us of that nature is that it always involves the superimposition of subject-object duality on an experience that is not primordially dualistic. So that whenever we're involved in perception, no matter how much we know that that's illusory, we regard the object as object, the subject as subject, and the object is given to us as it is in perception, as an independent object. That's kuntak, that's parakalpita, or imagined nature. And that is inescapable in ordinary perception. So if we think even of mental sense perception as a kind of perception, we have to think from this Yogacara analysis that it too is subject to kuntak, to parakalpita. And so we also worry that when we introspect, we impose that same subject-object duality, that same conceptual construction, that same kind of illusion on our perceptions. So the other alternative, of course, is Rangrig, is reflexive awareness instead of this kind of introspection. The problem, of course, is that for Umapa, for Madhyamakas like you and me, and especially followers of Je Rinpoche, we can't really affirm Rangrig. It's not accepted within our tradition, but more than that, it's not accepted for very good reasons. The idea of a single state being both subject and object doesn't really make a lot of sense. Moreover, though, even if we could make sense of reflexivity in this case, of Rangrig, it's not going to help us. Because if what we're trying to do is to figure out the nature or the content of a particular mental state or mental episode, and we don't already know it, then using that state itself to reflect itself isn't going to be of any assistance. Because if we don't know the nature of the state and we use the state we don't understand to tell us about itself, it's just like having one boat about to go over a waterfall and trying to save it by tying it to another boat in the same stream. They're going to both suffer from exactly the same problem and be equally non-understandable. These same issues arise when we look at Western approaches to introspection and self-understanding. The most common way that Western philosophers right now think about self-knowledge is as a kind of higher-order perception. That is, the use of something like a yuangshe, a mental sense faculty, to look at other internal states. But the problem is that, again, this is meant to generate knowledge, and knowledge of the nature of mind. And if it's going to be knowledge, that is a claim that we can actually make and assert, then it needs a kind of judgment. We already need ascertainment. We need to have an assertion. We need to have something cognitive, something conceptual. If I just see a red patch, I don't know that there's red in front of me. I only know that there's red in front of me if I know that I'm awake when I'm seeing it, that my color vision is okay, that the light around me is normal. Then I can put all of that knowledge together to generate the knowledge that I've got a red patch. So simply being aware of my own inner states doesn't give me the kind of knowledge that I need in order to do science. But to do this kind of categorization, to do this kind of conceptual work, to turn inner awareness or inner consciousness into knowledge, requires that we use concepts and that we use a particular conceptual framework. Say the Abhidharma framework, as Thupten Jinpa suggested this morning, or perhaps a framework from modern science. But those are different frameworks. And whichever framework we use is going to determine what we find. And so if we're trying to figure out which framework is right, we don't have a place to start the investigation. If we take a look at the big picture that's emerging here, I want to begin with a remark that the mid-20th century philosopher Paul Feyerabend made. And that is that our senses are just as much measuring instruments as our telescopes or microscopes, or you might say Professor Davidson's fMRI machines. When I look at something through my eye, what's happening? Light's coming into my eye, things are happening in there, and the eye is an instrument by means of which I know the external world. Just as if I don't know how a telescope works, then seeing something in a telescope doesn't allow me to gain knowledge of it. Or if I don't know how an MRI machine works, looking at all the data that come out, don't tell me that there's a brain in there. If I want to understand my perceptions, I need to understand how my eyes, my ears, my nose, and so forth work. And that, of course, is why cognitive science is so important. But it means that we need to understand the instrument. So unless we have an adequate theory of how an instrument works, how a sense organ works, how a sense faculty works, it doesn't deliver us knowledge. Now, if what we're trying to do is to figure out how the mind works, we need to know how the instrument works by means of which we examine the mind. And if we're using the mind to examine the mind, then the very object we're using is as mysterious as the instrument, and the instrument is as mysterious as the object. If I don't know how the mind works in the first place, and I use it to examine the mind, then I have no idea whether the information I'm getting is true or illusory. So that means that even a highly trained mind, of the kind that we all know that we need, is an instrument that we don't understand, investigating an object that we don't understand. So to conclude, all of us here, the entire Mind and Life project, is trying to develop a theory of mind and of life by using the mind. But without already having an adequate theory of the mind, we don't have any reason to take what that mind delivers as information at face value. We can agree from both a Buddhist and a Western perspective that even though we badly need these data, even though we use these data with some kind of confidence, we can only do so with the greatest caution and with the greatest tentativeness, because the very thing that we're taking to be a tsema, to be a pramana here, is something we don't even understand and is the object that is up for study in the first place. If we want to know what we are and how our minds work, we can't just look inside. Even trained meditators can't do that. We can't just assume that what we see is what's real, because the possibility of cognitive illusion is always there. The most deep illusion, I think, Your Holiness, is the illusion that we can just look inside and find our minds. And I think that that is one of the deepest signs of the primal confusion that generates samsara. And part of what we have to do as collaborators in Mind and Life, and this is not meant to be a discussion that undermines the work that all of my colleagues are doing, but supplements it, is to try to understand how an imperfect instrument can understand itself, which is the object for which we use it. Now, I'd like to pose a question to you, because this really is an important dialogue, and that is, once we recognize this terrible paradox, that the thing that seems closest to us, that is ourselves, our own mind, the thing that seems as though it should be the easiest thing for us to understand, is so opaque, so hidden, and so hard to understand. How do you see resolving this paradox and coming to be able to use the mind with some confidence?
Shebe ngo da chawa da digi de wenzen che le sheba mo de pe che me du kala di kang e da da tuna yong ya da de ngen ga yu du kala da di ji le ke tu be to ne sheba pe che che ene lo yu da da tu zu ya de ze nge ba ni tu ya da shi ru ka yu nas.
Of course, actually every moment we experiencing the mental consciousness. However, usually you see the sensorial consciousness is the major cause.
It's a dominant force. Yeah.
Dominant force. So in order to know, or in order to get some experience about mental consciousness, firstly, you see, we have to try to stop the active sort of
sensory activity.
Sensory activities, right? So usually we call some kind of thoughtlessness. Tadi ngande shibe jimju maungboy ngumisu tate shiba somo majuba tatigantayati.
So this is why one of the important techniques for meditation practice is to really try to find a stance so that you don't get hijacked by projecting your thoughts into the future or some kind of reflection or memory of the past, but rather staying within the present and kind of with a fresh moment by moment experience.
I also used to try to meditate, that kind of thing. So, not easy, but sometimes, you need the duration of that thoughtlessness. At the beginning, you may feel some kind of empty. Because namjutang 가서 그게 공연 시험이 시험도 급될 수 있어.
Because
양의 이 시간에 있는 지금 참바도 마음과의 문수다 뒤에 또 급시도.
Because in our normal day-to-day experience of consciousness, it's so dominated by object orientation, whether it's at the sensory level or even at the mental level. We're always kind of obsessed with, distracted by some kind of thought related to future or past. So it's so object-dominated.
So at the beginning, some kind of empty sort of feeling.
Absence.
Absence. Then try to remain there as much as possible. Then gradually you get the feeling of the very nature of consciousness, something clear. Reflection, reflection.
So you get a sense of a sort of a clarity, almost like a mirror, that although in itself there is no specific content, but it has this ability or the quality of being able to reflect.
So
for example, like if someone is cultivating single pointedness, focused on the mind, this is one of the steps that one needs to go through. So the practice involves, the training involves actually cultivating a single pointedness focused on the mind itself, where you cultivate calm abiding. And once you have attained a degree of that focused attention on the mind, then you take the mind itself as the basis and then look at its activity. Its arising, its cessation and so on.
And also sometimes it is quite useful when we develop anger. If you make attempt or make effort, then we can develop some kind of anger as an object. The mind observer. So your mind can observe anger. That is the first step of the sim mix. Sim mix lo self kim do. Ta sim chira wo chigi. The anger shuk chum level ka do de tatil pados. So sim kambu anger kan ma chim che sim suji anger do devina.
So part of the problem probably comes from the very idea of mind observing itself. Because when you talk about mind observing itself, we get this kind of very almost unmanageable idea of mind looking at itself. So perhaps a more feasible way of looking at this is to take a specific instance, like an anger, rising of an anger. Through training, one can cultivate a skill so that when anger arises, you do not allow your mind to be totally overtaken by anger, so that you from a corner of your mind, you can actually observe the anger as it arises. So that's a more specific application of introspection.
Oh. That's sometimes quite helpful. That the intensity of anger automatically reduces. Sometimes I practice that, but not always. Sometimes anger becomes more dominant.
Your Holiness, may I make a contribution? One of the Mind and Life programs concerns craving, desire, and addiction, as you know. We had a little research group that did very much like what you just described. We did an exercise, the 6 or 7 of us together, and one of the exercises we did was to come into a contemplative state. Each of us was a long-term meditator. We came into a quiescent, peaceful, harmonious state, and then we placed into the middle of that what was for us a desire that was particularly difficult. So you had this wonderful state of equanimity, and then you placed desire into the middle of it. And then you could feel how the space of the mental space was shifted by the presence of that desire. And then you watched, in the way that you described, the same kind of unfolding, how it affected the body, how it disturbed the equanimity, how thoughts began to come in. And then you tried to eliminate it. And that struggle became part of the observation also. Did you suppress it? Did you hold it and let it go easily? Did you make use of it in order to come to some other state? And then we shared the experience with each other experimentally, you could say. The idea being that I'm an experimentalist, Jay's a philosopher. Sometimes just trying things out, doing it together in the company of other experienced meditators, might be a way of exploring just exactly the space that Jay is pointing to.
Long.
Double. Sometime. I think it's a double.
Long.
Should the question.
And did it chumben and it took the Bayan Leon to Galanyako, Tonya Lolia, Yukun Debatan, the Dukudos, is the Kantachi, some new Tonya, Lola Jebas, Labdugan, Lols, Machapin, and Yam Yongu Tonya, La Lentarshana, and the Dig Tonya, the Yukuras and Kudukanamanish.
Some meditator, some my friend, when they meditate, more type of single-pointed meditation. Some of them, you see, can stay their single-pointed mind a few hours. Then gradually, the grosser level of mind, the activities, grosser level mind, reduce. So there's some experience of very nature of mind,
consciousness
becoming something clearer. So through training, through effort, it is possible, to gain more of the deeper level of consciousness through effort. And illusion said, "Didn't you also start that?
So you talked about the problem of illusion, but that's really a very difficult one. I mean, you find illusion in all the discussion of illusion in all the Buddhist schools of thought, in Vaibhashika onwards.
Any illusion.
And also, there is an understanding that depending upon the kind of philosophical views you uphold vis-a-vis the natural reality, your characterization of what constitutes illusion may also vary.
Exactly. When Umobo Sumina, the Simjing Shebala, Pagwe Nyamsha Yishi, Madova, Simjing Shebaina.
In fact, the Madhyamaka school even make the statement that insofar as the sentient beings' experience of mind is concerned, except in those rare moments when there is a deep meditative direct experience of emptiness, all the mental states are fraught with the illusion.
So then the
question is raised, in that case, does that mean there is no real knowledge? And then the answer is that knowledge is really defined in relation, through valid cognition. So valid cognition, validity is really defined in terms of its function in relation to its primary object. But just because an instance of a mental episode is valid does not mean there is no illusory component to it. So one can be illusory in the perceptual level, but at the cognitive level could be valid. So this is why in Buddhist epistemology a very important distinction is drawn between different types of object. Even in relation to a single mental episode, you have a perceptual object that appears to the mind, then you have the object that is the engagement, and the cognitive object, and so on.
Well, in the natural science, there are many phenomena. It looks like illusion for the layman's mind, but it's actually the true phenomena over there. I think the author is next on touches on that illusion and the real world mental understandings.
Yeah.
And can you take over the discussion to continue to this illusory perceptions and quantum physics?
I will
allow me to do that.
Absolutely.
Thank you very much, Jay, for a nice introduction.
Thank you. Wonderful. Wonderful, wonderful.
Well, needless to introduce the next speaker, who is the professor of science. He's not just a president of the Mind and Life Institute, but he's a professional physicist. And he's going to tell us about the quantum physics and the mind.
Yeah. Yes.
Arthur, please.
Thank you. I can't help but begin with a quote from Goethe, the German poet and philosopher, who said, "There is no such thing as optical illusion. Optical illusion is optical truth." And I think we learn perhaps even more from these illusions about the nature of cognition than from the normal experience of everyday life. They wake us up. They make us more conscious to the truth of our own cognitive capacities. And in some ways, quantum mechanics... In some ways, quantum mechanics challenges us similarly to the way in which Jay described the challenges of illusions, optical illusions. You can ask, what in the world does quantum mechanics have to do with the mind? Quantum mechanics is about the outer world, the world of nature. The mind is all about the inner world. But these two worlds, the outer world and the inner world, you could say, meet in observation, in the act of measurement or perception. And so I'm going to not only speak about quantum mechanics and its particular character, but also how the act of observation, you could say, affects or has a disturbance that's particularly puzzling in the case of quantum mechanics. Here's a Phuket shot, I think, down in Klaus's beach. But anyway, it's just meant to represent the act of trying to understand the world around us, which quantum mechanics and modern physics have explored. Here are two, Heisenberg on the left and Niels Bohr on the right, and they say to us something about the task of science. Bohr in Copenhagen wrote, "The task of science is both to extend the range of our experience and reduce it to order." Extend the range of our experience, that's the whole empirical content, but also to bring the mind reason to it, that we perceive order within that experience. I'll come back to that when we're speaking about the nature of meditative experience. Heisenberg, much younger than Bohr, but brilliant, spoke about the conception of the objective reality of the elementary particles has evaporated, not into the cloud of some new reality concept, so he rejects realism, if you will, but into the transparent clarity of mathematics that represents no longer the behavior of the particles, but our knowledge of this behavior. The distinction is clear. It's what we experience, the knowledge we have, not the hypothetical particles that are supposed to really be there. So he takes a more nominalist position.
Quantum mechanics ki rangon tube dana tu tendi giti map sugorba the map sub ti yango tu te mo sa ba chi kyo pa ke jamares quantum mechanics ko tone nyebe tendi giti tu te nam ju kares ti che resin che to mares ne tu te nam ju ma ju kares ha ku yo res chi le yo to lo chu ja je.
So we're meant to bring order into experience, not into some hypothetical world, but just the direct experience available to us through measurement, for example. How do we order that through mathematics? Now, I'd like to explore this surprising power of observation that fundamentally disturbs what it observes and even destroys certain kinds of subtle quantum mechanical interconnectedness or holism. And I'd like to relate this ultimately to the nature of mind, to the subtle nature of mind. Heisenberg is most famous for his uncertainty principle, which puts certain limits on observation. The relation on the right is a mathematical one, we'll leave it to the side. On the left is an image of a kind of microscope. Down at the bottom of that microscope there's a particle, an electron, that comes in from one side. There's a illuminating plane, illuminating light. And then one looks at the image of the electron having scattered light into the optical lens, and one then sees, if you will, what the position is. Heisenberg's uncertainty principle says that if you reduce the uncertainty in the position by a careful measurement of the position, the uncertainty in P, the momentum, increases accordingly. So you have one or the other, never both. And yet these two, X and P, position and momentum, really are meant to describe the reality, which now is limited by the uncertainty relationship. So the disturbance limits our knowledge. We are active. in our knowing through the disturbance, our knowledge becomes limited. Now you can ask yourself, is this a epistemological limitation? Is it the case that there really is a value for X and P, for position and momentum? Or is this an ontological limitation, that to say there is no position unless it's measured? There is no momentum unless it's measured. This is a fundamental statement about the nature of reality then. Is it nominal or real? And most physicists would say it's a limitation.
Quantum quarks.
So am I right in interpreting to His Holiness that the point being made here is that you can identify two attributes of the electron. One is the position, one is the momentum.
Yes, which think of speed. You can see where it is, or you can see the direction and how fast it's moving, but you can't see them both at the same time.
So the more knowledge you have of one, obscures
the other disappears.
Disappears. Yeah.
So you get focused on one, the other disappears.
So His Holiness is wondering, so, one interpretation would be it's an epistemological problem.
Right.
So, you choose to select, to focus on one attribute versus the other.
Yes.
Quark number 1, number 2, number 4. I think sometime back, I think at least maybe 15 years ago, CERN, there, one scientist is mentioned. Up to now, they found 3 quarks. Number 1, number 2, number 3. 4, not yet finalized. But there must be, could be, they say. So further sort of divide, you can't find any cause of that. Any particle. So, position.
So His Holiness is saying that as you go down deeper and deeper, like at the quarks level, then that very idea of position wouldn't make sense, would it?
Right.
And then moves.
Then
you
cannot even speak of momentum either.
Yeah, this is where quarks is a special case because they're confined. They never occur, and you can't ever see one isolated. Unlike an electron, where you can have an isolated electron, quarks always come bound in pairs or in threes. So they're hypothesized.
So it's not a pure figment of imagination.
No,
it's a fact.
Yes,
it is particle.
It's a particle, but it's a particle. Again, it's like what Jay was saying. You have to ask, what do you mean by particles? Like, what do you mean by an illusion?
So yoga acharya, external measure.
But the Yogacarans don't ask Yogacarans because they deny even external reality.
Well, I'm going to get close to that. What I'd like to do is in some ways skip to the end. Because quantum physics can take us all month.
Oh, this is it?
Well, that's a nice picture of Einstein. We should...
Oh, Einstein, yes.
Right? Do you ride a bicycle? No.
Yes.
You do?
Yes.
Good.
Not only writing, but also few experience of fell.
Okay. I'm going to switch to the question of observation and quantum holism. One of the most fundamental features of quantum mechanics is not only this disturbance that arises in measurement that has the microscope as the example, but a certain holism that arises through the interaction of two particles with another. So we might have two electrons, for example, that collide with one another. And when they collide with one another, they form a hole. Now, it's a kind of hole which is unlike our normal experience of this. If we take these two blue, we hit them together, you still, there they are. They don't change their identity. In quantum mechanics, however, when you hit two electrons together, their properties mingle in ways that mean that you can't distinguish the one object from the other object.
No.
Yeah. They come together and form a whole. They form a whole. Now that whole can be used for quantum mechanical calculation, that is to say, a new kind of computer. The quantum computer can use quantum holism as part of its machinery, but it only can do so as long as it's not observed. If it's observed, then the holism breaks apart and you have, like you have here with the two candidates. All right? So we have a tendency to model human thinking on classical computers, the kind of thing we have here, which has very discrete states, right, that change over time, like a logical system. No holism involved. We think one step, next step, one concept, the analytical meditation, very, very orderly. In quantum computation, you have ambiguity classically. You have, you could say, two objects, but their attributes are entangled in ways which are almost inconceivable, really, in a normal classical way. And yet, there are calculations which are able to be performed, which classical computers would take billions of years to do. Quantum computers can do in a matter of seconds. So that certain problems...
quantum level computer
And so, Your Holiness, what I'd like to suggest is that the model of the mind which we currently have in education and common understanding is modeled on this device. And what I'm suggesting is that's too limited, that the form of consciousness, the form of the mind and mental activities, which are good analogs to this, are only one aspect of what is possible. And so the question arises, is it possible to think like, or to have the inner mental states, not only like this classical computer, but of a quantum computer that works with subtle interconnected wholes that then would allow one to understand domains of reality that are subtle as well. I know within the Buddhist tradition there's a concept of gross, subtle, extremely subtle, and so forth, states of awareness, consciousness. Is meditation perhaps one way of moving between one level and another, the way one works in moving from discrete classical computation to the model of quantum computation? Could quantum computation be a kind of model for a new way of thinking, a new way of conceiving, a new model of the mind? So that's what I'd like to contribute as a way of thinking between quantum mechanics and the mind, with the interesting caveat that observation collapses the quantum computer into a classical computer. In other words, let's say there's a meditation state, and then you want to speak about it. As soon as you want to speak about it, you have to use classical ideas and concepts, and that whole thing crashes. Same sort of thing happens in quantum mechanical computing. If you look inside and say, what is the state, it collapses. So you have to suspend your classical conception until you get to the end of the algorithm, until you get to the end of the program. I'd be fascinated to hear about, the connections you might see between modes of consciousness, gross and subtle, and the kind of discrete versus holistic character of quantum computation.
단데 남배중에 셰버타라가 시엔도 다 셰버라베 내가 그 유도제단다 셰버타면에 그 유제단 개발 연구를했어. 대나시 제엔도 다 고라섬 단단데 클래시컬 기 모델 그토네 담단단다 퀀텀 삼단단지도 퀀텀 내가야 간다 즉 내주망 보지 반내 강샤지 군지디가 and some 도박이온 되가라 야고 직도냐 다도는 제한테 직도냐 자고를 봤어. 대단한 신지.
안데 quantum physics도 quantum 사디 consciousness 간주로 말해.
So just a question, the word quantum is used in relation to quantum physics. So can one imagine in that, along the lines you're thinking to talk about quantum consciousness?
You could, but the...
딱 간다도 quantum physics도 차세니. 그거가. 차르시면 그걸로 아는 것도 타니 뭔지 수준이라고 그거 차샤다. 또 수준 뭐 차르시면 그걸로 라베원도 집에 타니디 딱 가려. 타니디 시고면 차서서.
Because if you examine our perception of the world and our concepts and the language that we use, it's very much.
But I think here we can say the object which we consciousness, sensual consciousness, so we engage at the gross level. So our kind of concept and the kind of engagement is really defined in terms of kind of objects of everyday world. So that's really the model that we use. Gross level.
And it's really at the gross level, and between the perception and the mental consciousness, it's really at the perceptual level, how the sensory apparatus really relates to the world. So the moment we think about quantum, that kind of objective world collapses because, you can't find anything.
Yeah, there are new kinds of relationships between objects that don't exist in the classical. That's the new resource. That's the new dimension of quantum physics. Is what we took to be. Here's one object. Here's another object. They're next to one another. Now they interact. Now they form a whole. If you ask a question and make an observation, then they fall apart again into one object, another object. But if you don't, then you can build a machine that works on the principle of this ambiguity. It's not that there isn't something evolving, but it's evolving in a way that is unique to the quantum world. Yeah? Now, is there a state of consciousness that could be trained on that reality? Not on the everyday reality, which gives us classical one or the other, but a subtle domain of experience where interconnectedness is profound and fundamental.
So in the Buddhist version, the logic of emptiness that uses kind of quest for the ultimate reality of things. As you dissect, deconstruct the concepts and the objects they refer to, then the gross kind of view of reality also breaks down, because you can't find anything that you can point to as the true referent of those terms and concepts. So that's a kind of a process similar. So this is why in the Madhyamaka text there is a statement that if our engagement, perception of the world, if we are not contented by the mere facts of things that we experience, and if we insist on looking for some kind of a true objective reference to our terms and the concepts, then you cannot find anything.
Yeah.
찾아가 the realism yomarasati. Objective yomarasati.
So it is in this way, the objective reality and realism that its supports are not accepted, they are rejected in the Madhyamaka.
지금 매번 왜서 매번 말이야.
But then the question is, does that mean that nothing exists?
이해버디 relative 간의 요르마도 absolute yomarasati.
So the response is, yes, things do exist, but not in an independent absolute sense. Mm-hmm. But only you can talk about the reality of things only in relational terms, relative terms.
내가 이제 과학설이 저 과학 제시시원해.
So His Holiness is just asking you with relation to quarks. Do you accept
existence of quarks?
I accept the existence of quarks and atoms and electrons and all of these things, but again, you have to understand what they are. Let me take a simple example. The electron. If you ask how big is an electron, it has 0 dimension. It's a point particle. As a point particle has no size. So now try to imagine something that has no size.
Size
it
has mass.
And
quarks are also.
So how do you, in that sense, distinguish between 1, 2, and 3, the quarks?
They have attributes. So they have mass, they have spin, they have location, but they have no size.
Location you are saying. And size location.
So how does that work without size and location?
Exactly. But this. So what are you talking about? You know, and quarks and leptons are thought to be, which is say electrons and quarks, are fundamental particles, in as much as they have nothing inside of them. They are point-like structures. They're point particles. So these attributes, if you will, which are qualities that one measures in the laboratory, they're the experience. They're the equivalent of experience. So one's extended experience into the level of the very small, in fact, to the level of the ultimately small. So frankly, I think of quarks as the same as tables. You know, in other words, they are experienced. Now, they have to be experienced in linear accelerators and things like that. But I don't think of them as somehow on the other side, the real thing producing experience. They are just another domain, another realm or layer of experience. And then we bring order into that experience, as Boris said, through the mathematics. Right?
So it's like an illusion or hallucination, but it really exists.
But it's structured, it's ordered, it's not chaos. And in that sense, it's real.
Could you allow me to give a little bit different angle of the question
Sure.
to the same matter? The quantum entanglement.
That's what I'm describing.
You mentioned about quantum calculation. If you apply it to the cryptography, it's theoretically unsolvable, but it is there. And for the layman's mind, it looks like some of the sutra. It's there, but it's difficult to solve, but maybe unsolvable, but telling the truth of the mind. Do you have...
No.
Suggestion.
So can you clarify it, explain it in sort of layman's terms?
Well, the entanglement and quantum cryptography.
What is cryptography?
It's cryptography.
Well, okay, so if you have, let me put it this way. If you buy something on the computer, they want to have a safe and secure transaction. So they encode, they change it to change what your order is, and they put it in code.
Yes.
Now, if you have 1,000 years and all the computing power of America, you can crack the code. Or with a quantum computer, using the new kind of relationships, you can crack the code like that. So that which was impossible becomes possible by a new kind of computing, a new kind of, if you will, thinking. But the classical computer, which is the model we have of our own thinking, is radically different and, you might say, simpler than the quantum computation, which is built on these holes, so-called entanglement. I think to go down that route would take us too long.
Yeah, that's right. We need the mathematics and the beauty of mathematics to solve this problem or describe this problem. And I think we can move on to other mathematicians.
Great.
Actually, I think many of you also, I think maybe similar, like me, come to here, expect something to learn. But when listen to these things, more confusions.
But Buddhism Sutra is more confusions, and there must be some secret behind it for layman's mind.
So in the Buddhist tradition, in the Madhyamaka tradition particularly, there is a statement that if you try to objectively find things which are true reference to the terms and concepts, you cannot find anything. That project is untenable. But at the same time, that does not mean that nothing exists. But then the question is, how do you resolve this paradox? And here, the concept of true truths is brought in. So at the ultimate level, we cannot say anything about the world, things. But at the relative, conventional level, we can expect order, we can expect causation to operate.
So even though...
So true truth becomes something very, very relevant, very important. Thus, sutra not only Mingzam Tazam Stoyangudwa.
So therefore, in the sutras, there's like such as the Perfection of Wisdom sutras, there's a lot of references to the phrases like, mere designation, name only, mere concepts, and so on.
But even though we don't understand, we feel that something, the truth is there. And that's direct feeling without understanding or knowing. But anyway, we can move. We need a conceptualization, a formalization of the ideas and concept through the mathematics, and we'll see the beauty there. And I would like to invite
mathematician,
Professor Shigefumi Mori. He's a famous professor of mathematics in Kyoto University and Fields Prize recipient. And please.
Your Holiness, I'm privileged to be here as one of the few mathematicians, if not empty, in front of you. And I would like to compare mathematics with art. And mathematics and art are generally conceived to have very little to do with each other. But
art
but through
so His Holiness, just because you talked about mathematics and art, so he was wondering what would be the relation between art and quantum physics.
Quantum physics belongs to art?
We'll come to that at the end, I think.
Art na quantum mare.
So
art and science.
Yes, through 40 years of experience of research as a mathematician, I noticed several similarities between mathematics and art, and that's what I'm going to explain. So mathematics is the basic language of science and technology. But actually it is much more than just a language, but often it is unrecognized. That's one of the important subjects I might talk about, but that's not the one today. So today I'd like to talk about the beauty. So mathematics is beautiful, but it is difficult to appreciate its beauty. I don't claim, I don't say that everybody should agree with it. So
should agree with it. Yeah.
So the beauty of mathematics lies in mathematical ideas, and if you learn elementary geometry, you might have experience in the effect of auxiliary lines. And it is difficult to visualize mathematical ideas. But so here is a very primitive one. I'm talking about Pythagorean theorem given a rectangular triangle like this. So it has three sides, A, B, and C. And then Pythagorean theorem says A times A plus B times B is equal to C times C. What that means is C times C, that is the area of this square, is the sum of two squares, one with size A and the other with size B. And so let's see how it goes. Oops. So here, I just moved two triangles. So this square is the rest of the four triangles, and that should be the same as this one. But then the upper part is the square with size B, and the lower part the square with size A. So that's a proof of this Pythagorean theorem. Of course, there are many, many proofs for this Pythagorean theorem. And so what's mathematical idea? Well, so giving a regular triangle, and we form this square and this sort of moving things. So doing this, an idea flashed into my mind, and I got it. And it is the moment I feel the beauty. That's what mathematical idea is.
Ti sursum tiki ti ta kili yo tu ni ko parulia dewa yo bati de yongor ti zikya binduga lan jema den chi den tourist.
So Pythagorean theorem, which on the left hand side it's not clear why it is true, but after this this movement we can see that it is true. And this is how to say maybe similar to a Buddhism enlightenment, like Satori. Yeah. So that's the mathematical idea. And I'd like to compare mathematics and other disciplines. Well, research objects in mathematics only exist in each mathematician's mind or brain. And it is difficult to compare with those in other disciplines. But still, something can be compared. So one is this, this comparison, engineering design versus mathematics. We compare attitudes toward beauty and work. And in the second comparison, it's impressionism and algebraic geometry. I focus on how to capture an object and create a piece of work. I will explain this terminology in a moment.
Then the impressionism is no job the algebraic geometry then it's the
So engineering design versus mathematics. So I quote two words, one from Fulath. He is famous with fluorine. So C60. So it's a molecule consisting of 60 carbons. As a whole, it looks like a soccer ball, or the geodome designed by Fuller. That's why it's called fluorine. I will show you some of it in a moment. And the second person, Weil, he's one of the greatest mathematicians in the 20th century. So Weil conjecture proposed by him in about 1950 has guided the algebraic geometry, his area of research since then. Okay, so I start with Buckminster-Fuller. So this is Buckminster-Fuller, and this is the postage stamp made for him. And this brain, this head, is the shape of a geodome.
Shape of a
geodome.
geodome.
Hemisphere.
Kabal politibutan jaguiwa. Taguti could chache. No, Tujume de Remotanashi. Tajapsha dual, Tigatamangzi that they were chagus.
So he had many talents. So inventor, architect, author, and designer. And I learned about this person from Professor Hironaka, and he he quoted his words in Japanese, but I'm translating it back to English. So I don't guarantee that this is the original word. So let me read it. Never conscious of beauty while working on a problem. But I feel that something is wrong after the work is done.
Where is Fuller from? Where is he from? He's German?
I think he's in the United States.
Yeah, American, yeah? American.
I don't know where he's originally from.
Yeah.
So, but I feel that something is wrong after the work is done if the solution is not beautiful. So beauty is not something he sort of look for while he's working. But after the work, if it's not there, something is wrong. That is his view of beauty.
지금 노르대요나 지금 마티대버 초기기도 이거레스 근데 지다다 태대요나 그런 제처럼 지금 나와샤제 뒤에도 그 뷰티다 അങ്ങ진이 되어요 지금.
So the second person, Andrew Weil. So this is Andrew Weil. He's a mathematician. So he visited Japan about 60 years ago, more than a century ago. And that time, a few Japanese mathematicians asked him, what is a mathematical idea? Very blunt question. And his answer was that it's hard to define, but easy to recognize in the paper. He may sound cynical, but I think this was the only way he could answer. This reminds me of a phrase in a book I read when I was young. It says that it is impossible to define culture. Once you define it, it's dead. I think it's because the culture is something dynamic. Once defined in words, its dynamism will be out. So, to whom does it occur? So I would like to know, actually, myself. So, to who can continue working without ideas? But again, it may sound cynical, but so how mathematical idea comes up? So it sort of, as I said earlier, it sort of flashes into my mind all of a sudden. So it's impossible to predict. So, for instance, to get it, I have to work till I get it accidentally or whatever. Yes. So that's what he mentioned, I think. And if you read these words just alone, sounds very cynical. But if you compare it with Fuller's words, it's a little bit sort of understandable. And actually, I wanted to ask Your Holiness, what is Satori? To whom does it occur? Maybe later.
Japanese kunjuki shetan jebena Satori is laptugulian. 대 태도 냠게 깨지게 시도
그래.
태도 냠게 그렇지 영화 사토리세 시도 것도 Japanese 고즈던데 enlightenment there's something 것도 the in 가다질 쓰기어래 아니 가도 용구래서지
지단 냠도 영화 또 캐스도
그래 단도 또 고즈던데 Japanese 그냥 코나스 투모 많이 받는
어디십니다 이네
러스
그래서 그래서 되고 있는 것이다.
So his Holiness was saying that he's not familiar with the concept of Satori. But in...
What about the Buddhism enlightenment?
That... Nambeshune shebe enlightenment labinas.
Enlightenment removing tak hada shiruk nawa.
So then you can speak in terms of many different progressive levels of enlightenment and awakening. So these are states of mind.
That's different. I see. Okay.
당연 지금 안 되게 냠슬로서. 이 냠도 영어야 가가리셔. 냠슬로도 전에 거라 담으심이 거라 즉 간다 대학 가는 오지로 금지로 또 지면에도 냠용 말봐.
네.
그래서 자야 냠슬들이 커도 돼 지금 쪼아체는 중앙이 봐. 거라 루불을 다 중대실 냠스도. 영어스라는 다 냠부터 하는 중심이 거라 남도도 삼단은 이 마용내지. 그 뒤에로 지고 안에 냠 근데 지금 ben다 가서 ben다 딱 가서 그래. ben다 최저 그치. 똑같은데 뭔구지. 그러나 똑같으면도 가다 영어에서 나 가서 그래. 소화로도 뭔구지. 냠부터 하는 중대비지. 딱고 아니 남중라 마용내지. 된 냠스지. 영어스로는 다 로짱 아니 저자용 저명 영어스로도 남도도 삼스타바이나 디용되지 되는 영어 다이네 냠 중대버디 가나 아니 영어에 밥 못주는 밥 가서도 영어 소리 냠 중대버디 가나 로짱 아니 주고 영어지야 냠 그전에 수파도 해야 되지.
So, however, there is a distinction drawn between spiritual experience on the one hand and spontaneous experience on the other. So you can have spontaneous spiritual experience, and these are, these occur in some sense unannounced. Whereas the kind of the deeper experiences are really arises as a result of cultivation. So whereas the spontaneous experiences, you cannot just invoke them. So under certain circumstances, they may just occur to you, but there is no predictability. So therefore, however, when you have these kind of spontaneous experiences, which are kind of spiritual, then by sustaining your practice, you can continue to, deepen those experiences. So the distinction is drawn between spontaneous experience and deeper experience.
The Japanese word is not.
So, but His Holiness is not familiar with this Satori concept and its relation to this.
So what I mean is the following. So I try to solve a problem, and of course, if it can be solved quickly, it's not a problem. So I have to think of it for a few days or longer. And several years later, all of a sudden I realized. So till then, the problem seemed too difficult, but at that moment it seemed so easy. That's the moment I feel beauty.
그래서 프로블em 한다디 시지직을 샤로 시지직 실시하니 마시베인디 그 프로블em 샤로다 그 시비니무디 프로블em디 가서 프로블em 멤버 말이 프로블em이 그 가서 그게 디토 양양 300원 개 인고 시로
네. 또 코란스나 양양 300걸이야 시마 두비네 그 샤샤 두걸네 제마도 톱적급적이야 디
That's
true, but still that moment of awakening, the moment of understanding that you experience, is connected with the hard work that you did before.
Yes, sure, certainly. Okay.
Perhaps, as some of you may have that experience. The daytime, when we think certain things seriously, then sometimes in dream time, also you see the thinking, analyze that. So sometimes, because of the deeper understanding may develop during dream time.
Exactly, yes.
I think one sort of factor, the daytime, no matter your mental consciousness is concentrated on a particular point, but still sensorial consciousness still ready to act. So dream time, the sensorial sort of consciousness now no longer active. So only mental consciousness. So it can be concentrated more deeper way. Maybe.
Thank you. So let me continue.
Yes.
So I'd like to compare Impressionism painting and algebraic geometry. So this is, it's not very big, but it's the kind of painting I mean. I will show you it's much larger size in a moment. And this is algebraic geometry, just an example. So x times x plus y times y equals 1, that is equation. That defines the unit circle centered at the origin. So in this way, equation describes a figure. So algebraic geometry studies a figure using equation, so algebraic tools. So that's
algebraic.
Algebra is the 가설 천재리야 안기다 잡제 당어서 드러나로리야 가서 그 메타바이 교다가도로 뭐시 교지지스 교교교스 비지고라 그 유치라버지 남산 주고 뭐지 디나시단다 구주 높조베 안지 나로리 알제르라냐 x and y 다 되잖아 다 디토네 수 천재게 그지시고
So on the Impressionism side, Impressionist painter like Claude Monet painted unpaintables. So he wanted to draw impression or light. I mean, you can't simply just paint them. Algebraic geometers like Grothendieck made an otherwise non-algebraic figure an algebraic one. Maybe it's hard to explain as it stands right now. I'll explain that in a moment. So I start with Claude Monet. So he's an impressionist. So this is what he said. Again, this is a translation, not original. So to me, an ever-changing scenery does not exist alone. It is given life by the environment, including atmosphere and light. It is only the surrounding environment that gives true value to the object. And I will show examples: Impression sunrise, haystacks, and Rouen Cathedral. So this might remind you a little bit about quantum mechanics or illusions. So this is Monet's Impression sunrise. So Monet wanted to draw haziness by drawing this hazy scenery, or he tried to draw impression. And critics at the time criticized that it's just an impression, not a painting. And that's how the name Impressionism was started. And this is Monet's haystacks series. So Monet tried to draw light by drawing haystacks in the light of various settings. His idea was to draw light through its effects on the haystacks. And this is Rouen Cathedral, but it's the same idea. So I just...
왜 그러네. 그다데 먼저 자신의 왜 리모트 티토에서 개요만로. 요말때 왜데 수전에 포인트가 그런 단계 놀라서 단데. TV에서. 그래서 리모트 모두가 TV에서 그러죠.
Okay, so this is algebraic geometry side. So this is a picture of Grothendieck. He tried to make an otherwise non-algebraic figure an algebraic one. So his idea is the following. A mathematical object is determined by the role it plays in a category. Category is a mathematical, technical terminology of environment. So the role in the environment determines the figure. So Grothendieck proposed a way to view a mathematical object from the role it plays in the environment. And he also created mathematical object, a scheme called the scheme, similar to Monet's haystacks and cathedrals series. So he studied an equation, something called the equation, for various prime numbers, 2, 3, 4, 5, etc. And put each, for each prime he drew a picture and put all the pictures into one. Like this. So for 2, 3, 5, 7, and so on. So in case of Monet, he had to draw many pictures. But for Grothendieck, since it's a conceptual one, he just drew one scheme representing all the pictures. Yes. That's my point. So Grothendieck captured objects like Monet did. And that's my comparison. And thank you very much for your interest.
Monet remote so 수시는 답단 그 돈에 근데 수시는 고란 남주로 맨다와 왕실 차용 거와 왕실 차되고 더 외를 되고 대나 신지 다는데 고란 대 geometry to geometry this way that pension 그 되고 제와도 천국으로 그 천의 당지 돈은 천국 되고라 그 천당디 고 쿠유디날 그 자와 가르치고 유매디 돈에 천부인 되고라 다른데 모네기 리모티브나 신게 그게 가다 지금 천마도에 전제 수업에 소리지 가고 타고 싶어서 지나 차였습니다.
Right.
So mathematics.
Your presentation also quite difficult.
Mathematics and art, they're totally different, but the attitude of mathematician to object is so much similar to painters toward object.
제거예요, 그렇지다. 지금 거의다. 이그 거보다 제제 여버지다. 아다 mathematics 지고 잘도 돼.
Right.
So can you describe your talk that to describe something undescribable by describing surroundings without describing itself? Is that what you want to say?
That's what Grothendieck tried to do. Yes.
And probably that's have a structure. It's like a mind or soul, which is undescribable by words, but we can, characterize the surroundings, phenomena, or environment. And that could be the Buddhism structure, isn't it, Jay?
Would this be another way to put the parallel that you're drawing? In each case, we start out with an object, and we might think the best way to capture the object is to focus on the object. But what we see by doing mathematics, in particular by doing algebraic geometry, is that we do much better to understand the object, not by looking at it, but by looking at the structure of infinitely many objects to which it's related, and abstracting from the single thing to look at its role in this complex structure. Similarly, Monet, in trying to understand the Rouen Cathedral or the haystack, instead of painting the single thing, paints it from multiple perspectives in multiple lights in order to understand the thing in complex relation to a set of abstract entities, to a set of conditions around it. And each of them drawing our attention to the idea that to understand a thing isn't to focus on it, but to focus on countless other things to which it's related, perhaps in very abstract ways.
So Monet tried to draw a light.
Right, right.
Right.
Not the cathedral. I mean, he drew a cathedral, but
Right.
his intention was to draw light.
Right. But light's invisible.
Yeah.
And this room has
That's
light
right,
in it, but you
exactly.
can't see it. But so you need to show it acting in different settings or different times of day or different times of year. And then by virtue of all of those different instances, you begin to get a sense for the way light lives in the space that's invisible.
That's right.
That's right.
Yeah, Goethe, again, my favorite poet, said, if you try to describe the character of a person directly and abstractly, it's kind of hopeless. But as a playwright, you write the play, and the person comes out on the stage, and they have a certain way of being and acting, and then you form an impression of their character directly.
Yes, that's right.
Right?
Yes, I agree with you.
Yeah. So you can't see character, but allow it to live, and then you form an opinion, you form an impression.
Mm-hmm.
You can't see light, but you can see what it does in the world, and then you form an impression of what light must be. And in mathematics, how would you connect that back?
Well, so to view an object from the viewpoint of environment, that's the theory of category.
Okay, great. So in that case, you get to know the mathematical object, not directly, but by virtue of its...
By its role in the
But role
environment.
in structure.
Yeah, the environment, the so-called category.
Not just one object, but all the relation of all the objects.
So to be an object is to be a point in a space of relations to others.
That's right, that's right.
And to be light is to be something that's related to physical objects in particular ways. So in either case, we think that we're focusing on a single entity very closely to know it, but we discover that the only way to know it is to stop focusing on the entity and to focus on the set of relations into which it figures.
Mm-hmm.
It looks to me to the contrast between religion and natural Western science, because Descartes started out 400 years ago by reductionism to reduce into the element and describe it. And he further described it to reintegrate it again. But our modern natural science tends to forget it, to describe the materials of the reduced component itself, by forgetting all the structures. Probably, this is my opinion, maybe I shouldn't say further for the moderator, but religion or those holistic structure from philosophy needs to advise a natural scientist how to reduce it. And then by inverting it, science could recognize how to integrate it to understand the whole. That may shed light on how the religious party and science have to try farther for the future. And can we extend the discussion in this way? Do you think it's appropriate?
I'd like to pick up on a comment His Holiness made about the hard work. So you have a mathematical idea, an insight, right? It may be that you've been carrying it for many years. Same thing in physics. You see this again and again, that you carried for many years, but you're working. And I think of neuroplasticity, the Ritchie's talk about the way in which the brain is shaped by acting again and again in a particular way. And if I, as a scientist, am struggling with a problem, first consciously, then unconsciously in sleep, consciously again, unconsciously, And the brain itself is adapting to this continual encounter, frustrating encounter, right? But then at some point, it's like the brain is adequate now to this cognitive moment, and boom, it seems obvious. Now you have the eyes to see it.
I mean, if it happens.
Yeah, sometimes it doesn't happen. Yeah.
Indeed.
Yeah. You know, it's coming back to the arts again. Cézanne, another painter of the same period, same kind of thing, was showing his work, which was rejected for many years by the professional artists, was showing his work, and the poet Rilke kept coming back to this particular painting. And he describes to his wife in a letter how he couldn't see it, he couldn't see it, he couldn't see it, but all day long he kept coming back to the painting. Until finally he said, I saw it and I had the eyes to see it. You know, this sense of development at the hand of a continual encounter, this way of learning, of reshaping. You know, Goethe has this saying that every object well contemplated creates a new organ in us. Every object, whether it's a painting, whether it's a piece of mathematics, or believe it or not, even quantum physics, you know, if you come back and you practice, you contemplate well, it's a kind of meditation on a particular object. Take the Kasina devices, you know, the 10 devices in Buddhist practice. You know, how do you learn to see them more deeply by virtue of continual return, contemplating well? It's a kind of way of practice and meditating a particular problem in that case. Then the insight comes, which before had been elusive.
관체,
나를.
관배.
나를.
양양 리버션.
디
로울 더블롱 돼서. 그래.
That's true.
Right? Yeah. It's a kind of local enlightenment, you know, on that.
나한테 지나가는 시대에 마시고 그도 더블롱 돼서 고대인다.
A realization.
So His Holiness was saying that in the Tibetan there is an expression, actually literally means the outbursting of the insight, or realization. So
this difficult subject.
So His Holiness is, you know, hoping, you know, he's going to wait for when that's going to happen in relation to mathematics.
Well, I don't think waiting's enough.
This kind of sort of meeting discussion is like a foundation. Now, further familiarize these things, then become easier.
But do you have a means how to wait, and do you have some insight when it comes down?
But you see, sometimes it never comes.
Yeah.
Never right. Do you have some predictions? The feeling that it comes, say, in an hour?
If there is, I would like to know.
According to Buddhist, according to Buddhism, of course, I think Japanese also, you see, majority of them are Buddhist. So we always talk about Tathagata Karma or Sugata Shindaya.
Buddha nature.
Buddha nature, seed of Buddha. So we all have the potential enlightenment. So then knowledge, step by step, and duration, not days to weeks and months, but eons.
Buddhist generally speaks in terms of eons and eons.
Some questions from audience?
Yeah. Let's open it up.
Yeah, we are now naturally transferring to the general discussion. So if somebody wants to jump in the discussion.
Anyone? Some questions, any subject?
Yes, please. Is there a microphone?
Claudia, there are mics over on the left of the stage, or on your right. You can see them by the photographer. That's it. If we bring one of those to the center of the room. Perhaps you can come up to the... Claudia, you can come up.
Your Highness, just comment a little bit when answering about mathematics, that there were different levels of enlightenment. Would you say more about that? You mentioned different levels of enlightenment.
This subject kwale komna rebeta ko shey sta ko in la la cha de subject kwaine da de nge enlightenment sa zo nang sim kita
re ta shi rimpa ka shi ji rimpa ka de mang bu sha chu song song rimpa zu ka shi ji kan des kan na ma na ka des.
Firstly is a heart sutra teatha gade paragate parasamgate buddhi so rimpa she ko.
So in the Heart Sutra, at the end, there is a mantra which actually refers to these progressive stages.
Thoma, so to speak, Tanda Miyujik, Tangeti Tup, Sambe, Loda Jebe, Rimurujik, Solom, Gatiche. That in a D, Miyu did to have Tandaria, that's all the Tomani, Tomani Talia, Gumjung, Shilki, Sane, Gatis, Gatinivache. Then they are something, and Nina Nuekadula, Parasangati, such. Then Tadum Mutintai, Tungsin Commerciaki, Parasangati, such. Then Tadu enlightenment, the Buddhism said. So that the only enlightenment, chisel.
So in relation to this Heart Sutra mantra at the end, Tathayata, Gade. So the first stage is really in relation to the... So the Heart Sutra mantra literally means gone beyond and establish in the enlightenment. So the gone...
Gone completely beyond.
No.
You left out one gone.
Gone and go.
Gone beyond. Completely beyond.
Gone completely beyond and established in the enlightenment. So the first gone really refers to the initial stage of, enlightenment, one could say. So where in the quest for truth, there, you're in some sense making the commitment to really search for the truth, and then as you deepen your understanding through that quest, you get to a point where you have a kind of a meditatively derived experience of that in relation to that truth. And this is the second stage, when, again, at that stage, still the experience is mediated. But as you deepen it, it can become spontaneous and direct, unmediated. That's another stage. And then that unmediated experience of truth, when further enhanced, it can become spontaneous, and then ultimately leading to the final enlightenment. So there is this progressive, and each subsequent stage is really dependent upon the preceding stage.
Even conventional level, of course, the kindergarten and primary school, then
middle school,
then high school. Then university, then PhD, like that. Because of field chignalia, so
that's analogous. So even in the conventional education setting, progressively your knowledge deepens with relation to a particular subject.
So Parasangati le pesciare. Kashane Buddhisota, so subject down that PhD, professor.
So many of the professors who are on the stage here, with relation to their own specialized subjects, field, they're in this final stage of Parasangati Buddhiswa.
Would that were true.
Any questions? Oh yes.
So I wanted to just raise a question and a comment about Jay's presentation. Jay talked about the calibration problem, the problem of how we can calibrate our own introspective awareness. And I would like to ask Jay, as well as Your Holiness, whether you consider Francisco Varela's project of neurophenomenology an effort to actually provide exactly that kind of calibration. And so the idea in neurophenomenology is that if we are actually inspecting a veridical quality of our internal experience, and if there is consensus in the description of that across different individuals, that would lead to a correlation between reports of experience and some third-person measure, a measure of brain activity or physiology. If we were all subject to the cognitive illusions of the sort that you were describing, we would not expect any systematic association to arise from that kind of enterprise. And so I believe that Francisco developed neurophenomenology precisely as a methodological solution to exactly this calibration problem. And I wonder what you think of that.
Sure. Should I start first, Your Holiness, and then you can tell the truth? Okay. Yes, I agree with you that Cisco was worried.
The subject goes, third person.
That Cisco was worried precisely about the calibration problem as he developed neurophenomenology. And I think that there's something obviously right about what goes on in that methodology, but also something obviously problematic. And I also think that there's a slight overstatement in the way you put the point at the end. So I want to try to get there without too much distortion. Let me first retreat to a classical Buddhist text to contextualize this, and that's Nagarjuna's Vigrahavyavartani, where he's worried about the problem of the relationship between pramanas and prameyas, between instruments of gaining knowledge, the instruments by means of which we gain knowledge, and the objects of knowledge. And he's countering... He's countering an interesting foundationalist objection to his own epistemology. And the foundationalist says, Nagarjuna, given what you're saying about emptiness, given what you're saying about the lack of determinate meaning in things, why in the world should we believe anything that you say? Because the only reason that we could possibly believe it is if there was some foundation that we could rely on, either certain knowledge of objects by means of which we calibrate the pramanas, or a certain understanding of what the pramanas are, the instruments for gaining knowledge, by means of which we could get the objects. But on your view, they're all interdependent, so we've got no place to begin. Nagarjuna replies by saying, you're right. Pramanas, means of gaining knowledge, depend upon objects of knowledge. Objects of knowledge depend upon our means of gaining knowledge. So when I go to the doctor to have my eyes checked, and I put on the new lenses, and suddenly I can see the letters. It's the fact that I can see the letters that validates that they're the right lenses, but it's also the fact that I'm looking through the right lenses that validates that those are the letters. And so we get this reciprocal spiral of justification. Now, all of that by way of background. I think that Cisco saw that when he was worrying about neurophenomenology. But while neurophenomenology is an attempt, and a very good attempt, and probably the best kind of attempt we can make to address the problem, it's not a method for resolving the problem. Note for one thing, a basic empirical calibration problem that emerges. And this gets at the last point you made, but then I'm going to come back. And that is that while we get consensus in some domains among some introspectors, there's also vast amounts of lack of consensus among people who, for instance, meditate in different traditions, and among people who introspect using different language and different kinds of conceptual categories. We see this, for instance, when we talk about affect or emotions. Depending on the kind of language you've got for emotions, you're going to introspect and find different kinds of states. So consensus is easy to overstate. Where there is consensus, we get good leverage. The second problem, though, is this. Leverage regarding what? On the external side, what we get are external measures. Perhaps they're EEG measures, perhaps they're behavioral measures, perhaps they're fMRI measures. On the inner side, what we have is a report, a narrative reconstruction, an observation of something that's happening inside. The calibration problem, in part, comes to our understanding of what that report means and what that's telling us. What we would like it to be is to be giving us something that's independent of and different from the external measures. Strangely, though, because of course it's verbal, it's one more external measure. And so what we end up calibrating is a report of my inner episodes, where we may get an agreement, and that's nice, with other ways of getting at those episodes. The illusion comes when I think that when I look inside, what I'm just seeing are those naked episodes available to me. The longer I've thought about this problem, and it's been bothering me ever since I started obsessing with Yogacara texts, and thinking about introspection and fallibility, and thinking about how often I'm wrong about the nature of my own conscious states as an individual. The longer I've thought that one of the greatest insights in the Yogacara tradition in particular, but in the Buddhist tradition more generally, is the ubiquity of illusion. And the fact that the deepest illusions that we often have are illusions about having finally found a domain where there's no illusion. Right? It's when I find that just looking inside, at least that directly confronts me. That's when I think it becomes fatal. So, I'm, as you know, as you well know, I'm no opponent of cognitive science. I'm an experimentalist as well. I've worked in foundations of cognitive science for a long time, and I believe deeply that only by doing science can we get a deep understanding of the mind. But I also think that as we proceed, we want to proceed with a kind of clear sense of what the obstacles are, and in particular, a clear sense of the obstacles that present themselves not as obstacles but as opportunities. And first-person methodology, just introspecting, even if we're highly trained and experienced, looking inside, is one of those things that looks like such a gift, but it feels like a gift that's got, Trojans inside of it sometimes. That's all.
Just one little comment. It seems to me there are good examples of where people get it right.
Yes.
In particular, you. By that I mean your trust in thought, or the mathematician's proof of a theorem, or Einstein's inference without any reference to experiment of special theory of relativity. What was he working with? He was working with thoughts. Close your eyes. Let all the empirical stuff sort of disappear and simply think. This is a mental state. And you can think accurately. You can especially think accurately. But to me, that extraordinary reliability means there is some place where you can be secure. Now, there are other places which are murky, which are my feelings. I don't have the clarity about my feelings that I have about the postulates of special relativity, or a theorem that might be proven in algebraic geometry. All right? And that I can even hear or follow you means that in my mind, I'm moving through a set of mental structures and affirming or disagreeing. that there are swamps and so forth surrounding it. Yes, that's the case, and we like to clarify those. So the question to me is more one: how does one objectify or clarify or make more lucid and make much more reliable, let's say, my worries and my observations concerning a particular desire or feeling? That, granted, full of possibilities for cognitive illusions. That's not to say one never makes a mistake in mathematics or makes a mistake in theoretical physics, but the very fact that you can know that there are mistakes. I mean, cognitive illusions of the sort that you were showing us, visual illusions. Well, of course, we are judging them incorrectly based on just one piece of information, but we can also correct and recognize.
That's right.
Yeah. And I basically believe that anything where there's a possibility of error, there's also the possibility of getting it right. They go together. You can't just have errors.
That's right.
Right? Otherwise, you're back in the situation where, well, now anything goes.
So His Holiness was saying that when we talk about illusion here, we need to keep in mind that the context in relation to which we are talking about that illusion is occurring. So otherwise we will not have any possibility of having any notion of knowledge or so there could be or valid cognition. So there could be instances of mental states or mental episodes which are veridical in relation to their primary object or content, but it could have an illusory dimension in terms of its perception. So that doesn't preclude that instance being a form of knowledge or valid cognition. So even in the Buddhist context, the kind of conceptual realization of emptiness is really understood to be an instance of knowledge, a valid cognition. But on the perceptual level, it is diluted. I mean, there is an illusory dimension because it confuses, it conflates the concept with actual truth. And there is also a perception of objectivity of the thing. Just the realization of emptiness does not remove or preclude the perception of objectivity to that mind. So in this respect, we also need to think about, for example, when we are talking about valid cognitions and knowledge, what constitutes knowledge also depends upon the kind of facts you're dealing with. So you have evident facts, where the primary form of knowledge is perceptual, because they are given more to direct experience and direct perception. But then when you're looking at things that are not so evident, then you need to use inference. And inference, sometimes a series of inference. And there is, in the Buddhist epistemological text, inference are, sometimes compared to a blind person who can, find the road, find the path through the help of someone else. So therefore, the inference is often compared to a blind person, and ultimately it needs to be grounded in some kind of empirical experience. So therefore, in the Buddhist text, one speaks of evident facts, kind of hidden facts or obscure facts, and then extremely obscure facts. So therefore, experiment becomes really an important part of that process. So for example, if you are using a form of reasoning, whether or not that reasoning is valid, you cannot judge in its own terms. You have to judge it in relation to some other context, some other frame of reference.
그냥 초중이야. 되네 미진쇼로 매번 코나이 봐. 튼조로 이게 봐 코나이 봐. 또 뒤리는 예고로. 뒤리 심주초로야.
So, for example, in the classical kind of typical Buddhist epistemological model of reasoning, where you use what is known as the reasoning with the triple character. So you have a subject, you have a thesis, and you have kind of a proof or a reason. So there are three members in that form of argument, structure of reasoning. So the relationship between the subject and the proof needs to be established first, and then the relationship between the proof and the thesis needs to be established. So the proof needs to be not only present in the similar class, but also it should be absent in the dissimilar class. So there are a lot of requirements for a form of reasoning to be valid that needs to take into account.
근데 이두다 모주베텐지 망해베텐지 아니 개켜사로다 가다도 저 모주버스잖아요. 가서 그래. 그래. 시다타되면 모주베텐지. 에 가야지. 정치 모두 모주베텐지. 디얼롤 때는 모주베텐지. 다들 뭔가 쉬울리도. 쉽고 쉬울리도.
So because of this, in the Buddhist logical text, you see such a detailed explanation of what constitutes a valid form of reasoning and what constitutes an invalid form of reasoning. And the reason why a particular form of reasoning is invalid, there are multiple explanations of the different variations and so on.
자자가 디디고 지범진이 지범진 시야도 가고르샤. 십사고 감로가 패지르샤.
So that suggests that you cannot really make a generalized point. So you really need to be more specific when we're looking at the validity or invalidity of a particular statement.
망구지 김세고야 망구지도가 튼조로 통점 미든초로 마통점을 망구지.
Because often in everyday situation, many of the reasons that we use tends to be observed in the similar class, but not necessarily exclusively in the similar class. And so you have not observed it in the dissimilar class, but it hasn't precluded in the dissimilar class.
Now it's our turn.
So therefore, earlier His Holiness was saying that he mentioned how important it is for the Buddhist to really take the pramana text, the epistemological text, seriously.
Thank you. I think our time is up.
Yeah, we're running short of time. And thank you very much, Your Holiness, for giving us advice. And thank you very much for the speakers. And thank you very much for the audience. And could we have a short, could we have the honor of having a short closing remark from Your Holiness?
Nothing.
So now we are ready for tomorrow morning.
그도 잡아지기 쉬고요리. 시간 지다 골 티셔, some t-shirts have to 가게입니다.
So His Holiness was saying that whatever comes to his mind, he spontaneously responds, okay. But he doesn't have any prepared kind of comments.
Okay. Any my talk or participate to discussion, nothing prepared. Just sit and listen, then spontaneous sort of that. So
whatever comes up, then spontaneously he shares. Yeah.
All right. So thank you very much.
Thank you.